Okay, cool. All right, so yeah, I'm Kirk Haines, and today we're going to be talking about, it's sort of half historical survey and half a look at kind of pushing the boundaries of what people normally do with Ruby to see if we can move it into some of the areas that people don't normally think we should be using Ruby software to do things with. So first of all, just a little bit about me. I've been doing Ruby since 2001. I did my first professional gig for developing a web application using Ruby in 2002. It was a job search application for the Milwaukee Area Chamber of Commerce, matching companies who were looking for college interns with the college interns. And since then, I've done dozens of sites and apps and multiple web servers and similar sorts of things. I work for CookPad these days, and you can reach me. I'm yhaines pretty much anywhere, and kirkhaines at cookpad.com or yhaines at gmail.com. Any of those will get me. So I've got too many slides for my time slot, so I'm just going to dive right into it here. We're talking about what a stack is when we're talking about web applications. And a stack is basically all of the software that enables our application to do what it needs to do, or the stuff that lets our application talk with the end users out in the world. And breaking it down into layers, these are the layers that I've identified as the key components of a modern web application stack. We may not always use all of them, but these are the key components to a modern stack. Now, most of the time, Ruby is not used for all of those layers. And in fact, the only one that you will consistently find Ruby used in is the app container layer. There we go. That one right there. These layers down here, you can, Capistrano, probably lots of you have used Capistrano. Capistrano's Ruby software. FluentD is a system to aggregate all of your system logs and let you do wonderful things with it. That's done in Ruby, and so if you're using FluentD, your log aggregation, log management is in Ruby. And then your configuration management for your various instances. If you use Chef or Itamea, you're using Ruby software for that. But those other layers, typically you don't see Ruby software used in those layers. And I, on the other hand, because of the history of how I came to Ruby web app development, that sort of thing, I have some production applications that I did, in some cases well over a decade ago, that are still running on stacks that are completely Ruby from the top down. And so I'm going to kind of show you how I got there, and then we're going to explore how you can use Ruby software to infiltrate some of these other layers in a way that actually works pretty well. So when I started Ruby, I actually started before 1.6.7. That was just the bottom of the list on the Ruby Lang releases. My first version was 1.6.6. And at the time, web development was very different than the way it is now. There were no frameworks. There weren't very many tools. I came to Ruby from Perl, and in the Perl world, there were a lot of tools. And when I started looking at what there was in Ruby, there wasn't very much. Amrita was a templating system. And other than Amrita for templating, pretty much all there was the CGI library that's in Ruby itself. There was something called Mod Ruby, which let you embed Ruby inside your Apache process, which was kind of cool, and at the same time brought with it all sorts of terrible things. There wasn't even, ERB wasn't added until almost the end of 2002, so there wasn't a lot available. So your typical Ruby web application stack, such as it was back then, there wasn't one. I mean, there were very few people doing anything with Ruby and the web at that point in time. Now, around that time, I tripped across a proof of concept web framework that was called Iowa. And a guy by the name of Avi Bryant wrote it in 2001. And it was fantastic. It was better than anything I had seen in my years of doing Perl. It was better than anything that was available for Ruby at the time. It just made writing web applications so easy. And one of the key architectural things about it at the time was that the web apps that were IO apps, they ran in separate processes. And they communicated with the web server via socket. And that was a bit different than the way a lot of things ran at the time. And there were a few different mechanisms for conducting that communication, but the key thing was that it communicated via socket. And that was kind of a premonition, I guess, for the way Ruby framework development would go in the future. And I took over that project. Avi Bryant had done it as a prototype, and then he took the ideas over to Smalltalk and implemented the Seaside framework for Smalltalk using those same ideas. But I took it over and made it into something you could actually develop with. And that's what I developed that first application on in 2002. Now, fast forward, oops, yeah, I fast forwarded in my brain to a different slide. So if you looked at the stack graphically at the time, it doesn't, my stack that I was running on doesn't really look too different from a high level to the way you would think about web applications now. You have a web server and you have it proxying out to some set of processes on the back end that is your actual application. And if you fast forward in time a little bit to when Rails was released, Rails really stimulated the economy and the ecosystem in Ruby. And it brought with it a preferred deployment mechanism at the time that it was still Apache-centric. Everybody ran everything on Apache in those days. And it used FCGI to communicate between the web server and the back-end processes. And when later on, you'll be able to just download these slides. And if you follow that link, there's an article from that time that goes into how you would set up an Apache MySQL or Apache Rails connection with FCGI, just so you can kind of see architecturally how it worked then. It's kind of interesting. But FCGI brought with it a lot of problems. People weren't happy with it. It was hard to manage server, what am I trying to say? It was hard to manage your workload on your servers. If you needed to increase or decrease the amount of resources you had. There were deployment issues with it. It was, even while Rails saw a lot of adoption, FCGI was a constant pain point. And early in 2006, Zed Shah sent an email out to the RubyTalk mailing list saying, hey, I've got this cool new web server thing that I wrote in Ruby, and it's really fast. Why don't you take a look at it? And it almost overnight was adopted as the new preferred way to deploy your Rails applications because it was fast, it was standards compliant, and it eliminated a lot of the pain points that FCGI had. Architecturally, it was pretty much the same as before from a high-level view, although at the time, Nginx was starting to edge Apache out. And people were using Nginx more, and part of that was because Nginx didn't support FCGI really well. But if you weren't using FCGI and you were just using Mongrel, everything was beautiful and you could use Nginx. Now back in Iowa land, I never adopted Rails because for all of the sites that I was doing, it was just too big, too slow, too resource intensive, and it just didn't work for me. And so I had continued developing on Iowa, and there were all of these various ways of deploying Iowa applications. And they all, if you're coming through CGI or you're coming through Mongrel or you're coming through FCGI or whatever, you had a different representation for your requests. And so you needed an abstraction layer that took those different representations and all turned it into one consistent thing for your application. And so I had written something that looked a lot like Rack, but wasn't Rack. And as Rack came into being on the Rails side of the world, some of my code ended up getting pulled into Rack. And Rack really then changed how Rails apps interacted with, well, how Ruby web apps in general, not just Rails, but Ruby web apps in general, interacted with the world, because it provided a consistent abstraction layer for middleware, for any servers that you wanted to write. They all could work with your applications in the same way. So coming back to the idea of getting more Ruby in your stack. With Iowa, one of the things that made it really wonderful for developing apps is that it had this server-side state management. And it made things like, if you had a form, you had code, you didn't have to worry or think about how things were going to get from the form into your code or code into your form. It just handled all of that magically. You could just write code and reference things, and it would just work. You didn't have to think about the mechanics whatsoever. So it was wonderful. But the way that it worked, it maintained that state all within the process that your application was running in. So when you started to get into an application that couldn't run in a single process, you had more users, you needed to have multiple processes, multiple machines, you had a problem, because how do you get a request from your user back to a specific individual process on a specific individual machine? And there weren't any real load balancer options available at the time that could do it. And so I was just thinking, okay, well, I can write Ruby. I'll write something. And so what I needed was a basic web server that did a caching reverse proxy and had iOS session support. And when I asked around various other people, you can't do that in Ruby. Ruby is too slow to deal with that sort of thing. You need to write it in C or something else that's fast. It turned out to be pretty fast. These performance benchmarks are on a modern system, not one from 2007, 2008 when I was writing this. But I benchmarked these on a cheap $10 DigitalOcean VM. It's hardly a powerful system. And the original benchmarks on the equipment of the era, I don't have access to it anymore, but it benchmarked at about 15,000 requests a second, and this was Ruby software. It was pretty fast. And so then I had an epiphany. It's like, okay, well, if this can be this fast, if it can work this well, and it can do the job that I need it to do, it's simple to deploy, it's simple to configure, maybe I can stick Ruby in other slots where you don't normally see Ruby. And so this is what I ended up with as a production stack back then, circa 2009. I had my app instances that ran out on their various machines. I had a Swift apply was the name of the proxy that I wrote. And I had that running. All the requests from the world came into Swift apply. And then I had this thing called Logger, which was a log aggregator that I put together. And Logger was kind of another one of those things that came about because I had a need for something that I couldn't find in the ecosystem at that time. There were dozens of applications, processes everywhere, multiple systems running all these things, and so there were logs everywhere. And trying to debug something when you had logs spread across multiple systems and trying to analyze traffic or anything else was a nightmare because there were just these files everywhere. And so I wanted something that I could take all of the logging that happened within my application and send it to one place. And I could handle all of those logs in one place and do it. One of the key things is that I wanted to be able to do it without having any noticeable negative impact on the performance of the application. And so Logger is Asynchronous Logger. And again, it was one of those things, can it be fast? And so these benchmarks were ran on the same $10 DigitalOcean instance, but it'll log quite a few messages in a second. It also has failover handling so that if the logging server dies, the local clients just start spooling the logging messages to a system locally or to a file locally. And when the server comes back up, it just starts draining all those messages back out to the server as quickly as it can until they're all drained. And I mean, so that's what that performance benchmark is. I stuck in about once out of every 100 messages, I think. Once out of every 1,000 messages, I'd kill the server, and so then it would have to restart. And so it still keeps up pretty quickly, and that's all just Ruby. It's just Ruby handling those logging messages over the network. It was fast. Now in the 2007 era, again, the performance was about 60% of that, but it's proved the point. You could write Ruby code to do this stuff, and it was pretty fast. Even on, I was running that on 186 and 187, and it was that fast. And so some of the applications that I set up to run this way back in the late 2000s and the early 2010, 2011 timeframe are still running in production today. There's a major US bank that has a key piece of its mutual fund servicing infrastructure. It's used daily by hundreds of people. And it got put into production in 2011 with this model, and it just runs. Nobody pays it much attention. It just runs day after day after day. And it's Ruby top to bottom, except for the database. So then coming back to the whole idea of where else can you push the boundaries on this stuff. We have multiple layers here. And in my history, I kind of pushed the boundaries in this layer here. But there are other ways that you can do it. And so I'm just going to kind of skim through some of those because these are interesting bits of technology that are available in Ruby today that people may not know about, or you may not look at and realize that it's as capable as it is. And so the first of these here, End Proxy. This is a library that was actually written in 2011, and it is a layer over the top of Event Machine, which is a evented networking library for Ruby. And End Proxy hides a lot of the Event Machine implementation pain points underneath the DSL that is specifically designed for writing proxies. It's really blazingly fast, and it's pretty easy to use. Now, for the context of a slide, there's way too much information here for me to put anything in. But if you go to GitHub and you search for End Proxy, you can find these examples here, and this balancing.rb is a neat example because it's a fully functional HTTP load balancing proxy in less than 200 lines of code, and that includes some tests and documentation. And it includes things like multiple strategies for how it load balances on the back end. It does an impressive slice of what you might get if you use HA proxy for your load balancing, all in under 200 lines of Ruby code. And the center portion of the proxy is just this little bit of code. And it's fast, it's really fast. Now, another neat little piece of Ruby that tends to get ignored is WebBrick. People tend to think of WebBrick as a toy or as something that is kind of useful to play with, but you couldn't really use it for anything. But it turns out that WebBrick has a lot of capabilities built into it, and it's relatively performant itself. For the purposes of writing a proxy, WebBrick has libraries directly built into it already that lets you build a proxy. And I just put a link to another article that if you want to see details about how to build a proxy with WebBrick, it's in there. But it ends up being a few dozen lines of code, and you have a working proxy using WebBrick, and it runs fast enough that you could use this reasonably on the majority of websites that people actually use today. Most websites that people use aren't Twitter, and they aren't Facebook, and they aren't things like that that handle enormous amounts of traffic. Most websites and most applications see a lot lower traffic, and something like this is performant enough. Now, going along with the whole proxying layer and the load balancing layer, the static asset caching, what that means is that when a request comes in, we don't always want to send that request all the way down through our pipeline to the web server to get handled and return everything back. If we're just returning the static assets, we're returning our JavaScript, we're returning our images and things like that, it saves a lot of processing power if we can just cache those at a high level and return them, return a response to those requests right there at the high level without passing it on down to the stuff that takes more work to process it. And that's what a static asset cache does. It's really just a proxy with a little bit of additional intelligence. And you could write something like that with the End Proxy pretty easily, but Ruby has more than one way to do things. And so I was just thinking about this and thinking, okay, Puma. If you guys, any of you guys do Rails apps, you probably have used Puma. Puma's a pretty capable web server in its own right. And because it uses Rack, you can use Rack to write pretty much anything that interacts with the web. So what would it look like to write a static asset cache with Puma and Rack? And so I banged it out over the course of about a day. And it's on GitHub right now. It's called Shellac. It's a little bit of a punny name. Varnish is kind of the industry standard for a caching web server, and Shellac is a kind of varnish. So, and the code in it is relatively simple. There's more code in it to handle the command lines and the options and the configuration and that sort of thing than there is to handle the actual proxying and the actual caching. Now, given it's really simple. Right now, don't use it. It's alpha software. It needs capabilities that it doesn't have right now, but it sort of proves the point. So this is a really simple example of invoking it just on the command line without a configuration file or anything. And what it's doing is this is a route definition. It's looking for a request that matches this domain. It's going to apply this regular expression to it to extract some information. In this case, it'll be whatever is in the query string of the request. And then it's going to take that and it's going to plug it into this URL and proxy off to it. So effectively, what it'll do is it'll let you access GitHub without going to GitHub. And it's just a ridiculous little example just to kind of prove the point. I'm running it on the same cheap DigitalOcean instance that I tested the other things on, and it's actually running right now. If you go to RubyKaigi 2018.demos for us, and then do a / and like your GitHub username or something, you should get back your GitHub profile page. But benchmarking it'll do, it did 1,800 requests a second because it's not actually going to GitHub 1,800 times. It goes there once, gets the page, stores the page, and then it just returns the page from memory those other times. It proves the point, though. You can do this stuff in a relatively few lines of Ruby code, and it's pretty fast. Now, yeah, the fine print, the disclaimer, don't actually use it for anything because there's a whole lot of things. Well, not a whole lot. There's several things that it doesn't do that it really needs to do before it would actually be useful to stick it in front of any real traffic. It doesn't expire cache items. It doesn't actually pay any attention to the cache control headers to determine whether it should cache things or not. There's some things like that it needs to do. But it's kind of neat, and it didn't take much time to throw together. Configuration on it is really simple, and it proves the point that you can slot this stuff into your stack using Ruby. Now, talking about web servers, I I just threw this in because it never ceases to amuse me. This little bit of shell script and Ruby is a viable web server. I mean, well, it's an HTTP 0.9 compliant web server right there. You would never want to do this because it probably opens you up to somebody reading any file they want on your system. But it's kind of cool. Now, this is a viable web server. This line of Ruby here actually runs WebBrick, and what it tells it to do is serve static files out of the current directory. You replace this with any path specification, and it'll serve the static files out of whatever path you give it. And going back to the whole idea that WebBrick is just a toy, again, this was on that same cheap $10 a month DigitalOcean VM, and it's coughing up 2,700 files a second. I was using the README off of Shellac as the test file, so it's probably a K in size. I don't know. It's a decently sized file. It's coughing up quite a few of them, and it's just WebBrick right out of your Ruby distribution. And you can do the same thing with Puma. Puma requires a config.ru for anything that it does. It doesn't have any sort of default functionality, but a config.ru to serve static files is really simple. And so you invoke it with something like this that says 1 worker, a minimum of 2 threads, a maximum of 16, ran with this, and then benchmarking it on that same file that I benchmarked WebBrick on. It's a little bit faster than WebBrick. And Puma has the advantage of you being able to fine-tune workers and threads, and so if you're running it on a larger system or something like that, you can fine-tune what it does more than you can with WebBrick and probably get better performance out of it. But Puma can fly. It can go pretty fast, and if you want to compare it to Nginx, I set up Nginx on that same system and pulled the same set of files. So Nginx obviously outperforms it, but 3,000 to 4,500, it's not really a gaping chasm in performance when you're still talking thousands of files a second. That's pretty reasonable performance out of Ruby, especially when everybody always says Ruby's slow. Ruby's slow, C is fast, but we're there at 65% of the performance of the C web server with a Ruby web server. Now, the database layer is the one area where there are no Rubies. I have not found a single implementation of an actual database that uses Ruby. We have lots of interfaces to other databases that use Ruby, but not a single implementation of a database done in Ruby. I couldn't find one anywhere. If anybody knows of one, tell me about it after the talk. I'd love to hear about it, but I don't think there is. However, I have a crazy little idea I might play with. Key value stores, checking my time here. Key value stores is one of those areas too where people normally don't use Ruby software for these. You use Redis or you use memcached. Those are perhaps 2 of the most common ones in the Ruby world. And key value stores are supposed to be, they're not something that people think of using Ruby for. You use them for caching fragments or for caching little bits of detail or things like that. And so you want them to deliver their results quickly so that you can get on to constructing your web pages and return your results. But there's this key value store called Roma, and it's pretty interesting. I don't know, have any of you in here ever seen Roma? Okay, so it's a pretty neat little piece of software. It's a distributed key value store, which means you run multiple nodes, and what it does is it stores the data. You can configure exactly how it does this as far as how many nodes and stuff, but essentially it stores the data on more than one node. So if you go and you insert a key and a value in Roma 1, it's going to also stick that data out here on Roma 2 or Roma 3. And so if Roma 1 dies, the data still exists in the cluster, and you haven't lost any data. Now, I ran some benchmarks on it with a 3-node cluster, and I used the $5 DigitalOcean instances, the cheapest ones that they've got. And I was also using as a backend, instead of an in-memory data store, I was using a SQLite data store, so the data persists in case it's shut down. And the performance was not earth-shaking, but it was also pushing that data out to multiple nodes on each request, and it's on super cheap hardware. Now, Rakuten claims a performance of greater than 10,000 queries per second when you're using in-memory data stores and AWS instances. And the slides that I pulled that off of were from 2015. So I think when you're running it on hardware that isn't absolute bare bones, bottom of the barrel hardware, and you're using in-memory stores, it's pretty performant. And it also has multiple backends, and it's pretty extensible. Now, there's another layer that I find kind of interesting. Capistrano is commonly used for deployments. It's everywhere. It's battle tested. Now, I came from working in Engine Yard for 8 years, and I got really used to deployments that use Git as a key portion of the deployment infrastructure. So I wanted something where I could do something like this. I could be working in a branch, and I could do a Git push, and I want that code to just magically go out to whatever server or servers in the world are running off of that branch and get deployed. Or if I'm going to production, I can push that code to production from my workstation, and it just magically gets out there. So there's this tutorial here that talks about how you can use Git hooks to set up something where when you do a commit or you do something like that, it'll do a push to specifically targeted instances. And that's kind of interesting, but that isn't really exactly what I wanted, because I don't want to have to specifically delineate where I want the code to go when I do a push. I just want it to happen. And so I got to thinking about that. Now, Surf is a neat little tool by HashiCorp, and basically it's a distributed daemon, lightweight daemon that lets you run commands and run queries and stuff like that on your instances. It's sort of a messaging bus. And it's not written in Ruby, but it's really easy to use in Ruby. And it turns out I'm running out of time, so I'm going to go really fast here. I'm talking too much. So Surf lets you do things like this. You can send queries out and get responses back. Even detailed responses like the load average on this cluster, which shows that these machines are doing nothing. And all of these handlers, and so the configuration is really simple. And the key portion here is this event handlers. There's this thing called Surf Handler. And Surf Handler was something that I wrote while I was flying over the Atlantic coming back from the Cookpad offices last year. And what it does is it requires from a well-known location a little bit of Ruby that uses a DSL to define your handler. And so this is where it ties in with using Ruby for things. And with that, you can define more complex handlers. So this get index deploy goes and it expects to get a hash code that identifies a Git repository. And then it uses another little script called get index to see if that Git repository lives anywhere on the system. And if it does, it goes and it runs just a simple git fetch and git pull on it. And it also has some hooks for doing some after deploy things and things like that, so you can restart servers and that sort of thing if you want to. And Git index is a simple tool that just maintains, you use it to set up a database of directories, and it does a fingerprint of the Git repository there. And so you combine all of these things, Git hooks, Surf, and simple Surf handlers, and suddenly you have a working deployment system where you can do a Git push And wherever your servers are in the world, they'll get your code. It's a pretty cool little thing. Configuration management, that layer, like I mentioned before, it's already pretty well covered with Ruby. Chef and Itamea are both Ruby options that work well. Log management, I think covered that already. I think Analoger is a cool thing that nobody uses but me. But I think it's a cool thing and really demonstrates how you can use Ruby to do something quite quickly. And FluentD is also written in Ruby, and FluentD does all sorts of things. If you have lots of logs and you want to gather them together and you want to do things with them, FluentD is a pretty neat piece of software. I just threw in a couple other little things. RDFS is something that I tripped over that is a pretty cool example of using Ruby to do something complicated in a relatively small number of lines. It will synchronize file systems between multiple systems, and it does it on the fly. So as you make changes in one system, will synchronize those changes to other nodes, and it's all written in a few hundred lines of Ruby. And this is vaporware, something I'm working on. It's a SSH proxy for a Bastion server. So if you want to monitor what your employees are doing on customer instances or whatever, if you need to pass some security certifications, you can do that. It's based off of something that I did when I was in Engine Yard, and they gave me permission to open source it, but I never did before I left. So I started working on a new and improved version, and hopefully that comes out to GitHub sometime soon. So just wrapping it up really quickly, there are some versions of these stacks that I've had running in production for a decade or more. Rails apps, Iowa apps, both. And over time, I've tweaked little bits here and there to insert more Ruby. But they all, except for that database layer, they all run very stably in production with Ruby for most of the layers. And if you really want to push it, there's places where you can push it further. Now, reasons why you might want to do this are mostly it's simplicity, or you have a specific function that you want to enable that isn't easy to provide. The sticky sessions. HA Proxy does sticky sessions now, so if I were running into that problem today, well, maybe I could use HA Proxy. But if you have some specific solution, some specific problem, you can probably write it in Ruby. If you just want something that's very simple and does exactly what you need, it might be reasonable to write it in Ruby rather than using some big monolithic tool. Reasons not to do it: performance. I mean, while Ruby is fast enough, it is still not C or C++ or anything like that. And so if you really need to squeeze out every last little bit of performance, you might not want to do this. The other main one is security. You have lots of eyes looking at Nginx, looking at things like that all the time. If there's bugs in it, security bugs, you're more likely to find out about them. They're more likely to get fixed. If it's your own code and you only have a few people looking at it, you may have a security hole that you never realize exists, just simply because it doesn't get as much attention. But that's basically it. I think I've got like 2 minutes left. If you signed up to come to the Cookpad party, make sure you come. We are hiring. And if anybody has any quick questions, shout them out.
Hello? Okay. Thank you for a wonderful talk. Based on your experience, what do you think the source of the assumption that this cannot be done in Ruby?
Mostly it's the assumption that Ruby is too slow to do anything complicated. I mean, that essentially is what it boils down to. It's this persistent idea that the performance of Ruby means that there are things that you just can't do with it. And while to some extent that's true, and you know, a lot of that perception comes back from Ruby 1.8.6, 1.8.7 days. Ruby's so much faster now. But you know, even back then, a lot of it came down to how you implemented it. You know, whether you needed all the features or whether you could just focus on the few features that you need. And that makes a big difference in the overall performance.
So in your implementation, are you using some like restricted subset of Ruby or the standard library, or are you allowing yourself to use everything?
Oh, well, I mean, it's all the Ruby. It's just, yeah, it's all the Ruby.
Thank you.
Yeah. Probably, again, it's that idea of there's no way to make it performant enough for people to actually use it, so nobody's tried. I don't know. I wasn't able to find any examples of it, so that's just my guess.
It's Rubies all the way down. Thanks.